To become a licensed master electrician in New York City, there are several requirements that need to be met. Firstly, you must have at least 8 years of experience as a journeyman electrician. This experience is crucial for demonstrating practical knowledge and skills in the field. Secondly, in terms of education, you must hold a certificate as a journeyman electrician from a New York State-approved apprenticeship program or have equivalent education and experience. This ensures that you have a solid foundation in electrical theory and practice. Thirdly, citizenship or legal residency is a requirement. You must be a United States citizen, a permanent resident, or hold a work visa that allows you to be employed in the electrical trade. Fourthly, a good moral character is essential. You must have a clean record, with no felony convictions related to the electrical trade. Now let's delve into the details of the exam itself. The exam format consists of 100 multiple-choice questions, and you are given 3 hours to complete it. It's important to manage your time effectively and pace yourself throughout the exam. The test content covers a wide range of electrical knowledge. This includes electrical theory, which is the foundation of understanding how electrical circuits and systems work. Electrical safety is another critical component, ensuring you know how to work safely with electricity and prevent accident. A significant portion of the exam focuses on the National Electrical Code, known as the NEC. You need to be familiar with its articles and requirements. Electrical system design and installation are also covered, testing your ability to plan and implement electrical systems. Electrical calculations are another key area, requiring you to perform calculations related to voltage, current, resistance, and power. To pass the exam, applicants must score at least 70%. It's important to aim for a high score to ensure you pass. Registration is done through the New York City Department of Buildings website. Make sure to visit their website to start the registration process. The exam is typically offered twice a year, in May and November. Plan accordingly and choose a date that gives you enough time to prepare. Applicants must schedule their exam at least 30 days in advance. This ensures that there is enough time to process your application and reserve a spot for you. The exam fee is $100. Be prepared to pay this fee when you register for the exam. An additional $25 is required for late registration, so it's best to register on time. Preparation is highly recommended for the exam. Study materials can be found online, at local hardware stores, and through electrical trade schools. Consider taking a preparatory course or hiring a tutor to help you prepare. Now let's discuss some additional information. The Master Electrician's exam is valid for 10 years. After passing the exam, applicants must obtain a Master Electrician license from the Department of Buildings. Licensed Master Electricians are required to take continuing education courses to maintain their license. This ensures that they stay up to date with the latest codes and technologies. For more information, you can contact the New York City Department of Buildings Licensing Unit at 280 Broadway, 6th floor, New York, New York 10007. You can also call them at 212.387 3800. You can also visit their website for licensing information. I'll expand on some key areas of knowledge required for the Master Electrician exam, focusing specifically on the National Electrical Code, electrical calculations, and safety practices. A deep understanding of the NEC is paramount. This code serves as the cornerstone for safe electrical installations. Familiarity with key chapters and articles is essential. This includes Article 210. For branch circuits, Article 220. For calculations regarding branch circuits, feeder and service, and Article 250. For grounding and bonding. You should also know Article 300. Regarding wiring methods, and Article 408, which covers switchboards and panel boards, as well as Article 430. On motors, motor circuits, and controllers, including their overload protection. It is crucial to understand the requirements for conductor sizing, overcurrent protection, and grounding. You should be able to navigate the NEC to quickly find relevant information. Knowing how to apply the NEC to real-world scenarios is a key skill that will be tested in the exam. Now let's delve into electrical calculations. You should be proficient in calculating voltage, current, resistance, and power using Ohm's law and Watt's law. Ohm's law states that voltage equals current times resistance, represented as volts equals amps times ohms. Watt's law states that power equals voltage times current, represented as watts equals volts times amps. Be prepared to perform calculations for both single-phase and three-phase circuits. This includes calculating apparent power, real power, and reactive power. Understanding how to calculate voltage drop is essential for ensuring proper voltage levels at electrical equipment. You should be able to calculate the appropriate conductor size to minimize voltage drop. You should also be familiar with calculating the short circuit current to ensure that overcurrent protection devices can adequately protect the electrical system. Transformer calculations are also important. You should be able to determine the appropriate transformer size for a given load. Let's discuss electrical safety. A thorough understanding of electrical safety practices is crucial. You should be familiar with lockout/tagout procedures to prevent accidental energization of electrical equipment during maintenance. Understanding the importance of personal protective equipment, or PPE, such as gloves, safety glasses, and arc flash suits, is very important. You should also be familiar with safe work practices when working on or near energized equipment. Arc flash hazards are a serious concern in electrical work. You should be able to identify arc flash hazards and take appropriate precautions to mitigate them. Grounding and bonding are essential for electrical safety. You should understand the purpose of grounding and bonding and how to properly install grounding and bonding systems. A ground fault circuit interrupter, or GFCI, protects people from electric shock. You should understand when and where GFCI protection is required. Let's now dive further into the exam content, particularly expanding on electrical system design and installation, and some additional aspects of the National Electrical Code. Electrical system design involves planning and creating electrical layouts for various buildings and structures. You need to understand load calculations, determining the total electrical demand of a building to ensure the electrical system can handle the load safely and efficiently. You'll need to know how to select appropriate wiring methods based on the application and environment. This includes understanding the different types of cables and conduits and their permissible uses. Understanding how to design and install lighting systems for various applications is important. This involves selecting appropriate light fixtures, calculating lighting levels, and ensuring compliance with energy codes. You should be able to design and install motor control circuits, including selecting appropriate motor starters, overload protection, and control devices. You should know the installation requirements for various types of equipment, such as transformers, generators, and uninterruptible power supplies, known as UPS. The NEC is updated every 3 years, so staying current with the latest edition is critical. It's not enough to just memorize the code, you need to understand the reasoning behind the rules. Many NEC articles refer to other standards, such as those published by Underwriters Laboratories, known as UL, and the Institute of Electrical and Electronics Engineers, known as IEE. It's helpful to be familiar with these standards as well. The NEC provides tables and examples to aid in understanding and applying the code. Make sure you know how to use these resources effectively. The NEC contains specific requirements for different types of occupancies, such as residential, commercial, and industrial. You should be aware of these differences and how they affect electrical installations. Understanding the requirements for emergency systems, such as emergency lighting and backup power, is crucial for ensuring safety in the event of a power outage. Knowing the specific requirements for hazardous locations, such as those containing flammable materials, is essential for preventing explosions and fires. Let's further discuss the topics related to grounding and bonding and dive further into overcurrent protection. Grounding and bonding are critical safety measures designed to protect people and equipment from electrical shock and fire hazards. The purpose of grounding is to provide a low impedance path for fault current to return to the source, allowing overcurrent protection devices to trip and clear the fault. Grounding systems must be properly sized and installed to ensure effective fault current protection. Bonding is the process of connecting all metal parts of an electrical system together to create an electrically continuous path. This helps to minimize voltage differences and prevent electrical shock hazards. Bonding conductors must be properly sized and installed to ensure effective bonding. The NEC specifies different grounding and bonding requirements for different types of systems and equipment. Understanding these requirements is essential for ensuring safety. Now let's talk about overcurrent protection. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect electrical circuits from overloads and short circuits. Fuses are one-time use devices that melt and open the circuit when an overcurrent occurs. Circuit breakers are reusable devices that trip and open the circuit when an overcurrent occurs. Circuit breakers can be reset after the fault has been cleared. Overcurrent protection devices must be properly sized to protect the circuit without nuisance tripping. You need to know how to coordinate overcurrent protection devices to ensure that the device closest to the fault clears the fault without causing upstream devices to trip unnecessarily. The NEC specifies different overcurrent protection requirements for different types of circuits and equipment. Understanding these requirements is essential for ensuring safety. Let's continue to dissect the details of preparing for the Master Electrician exam. I'll provide a more structured approach to studying and some specific resources that might be helpful. Firstly, creating a study plan is essential. Allocate sufficient time for each topic and stick to your schedule. Break down the vast amount of material into smaller, manageable chunks. Focus on your weak areas. Identify the topics you struggle with and dedicate more time to them. Secondly, use the official NEC book. This is the most important study resource. Become familiar with its structure and contents. Highlight key sections and make notes in the margins. Thirdly, consider practice exams and sample questions. This helps you to get familiar with the exam format and identify areas where you need more practice. Fourthly, join a study group or online forum. Collaborating with others can help you to understand the material better and learn from their experiences. Fifthly, attend a preparatory course. Many electrical trade schools and organizations offer preparatory courses specifically designed for the Master Electrician exam. Sixthly, review electrical theory and calculations. Make sure you have a strong foundation in electrical theory and calculations. Seventhly, focus on code calculations and examples. Pay close attention to the code calculations and examples provided in the NEC. Eighthly, understand the grounding and bonding requirements. Grounding and bonding are critical safety measures, so make sure you thoroughly understand the requirements. Ninthly, study overcurrent protection. Understanding overcurrent protection is essential for preventing electrical fires and equipment damage. Tenthly, review electrical safety practices. Make sure you are familiar with safe work practices when working with electricity. In terms of resources, Michael Enterprises offers a variety of study materials, including books, videos, and online courses. The National Fire Protection Association, known as NFPA, offers training and certification programs related to the NEC. ElectricianTalk.com is an online forum where you can connect with other electricians and ask questions. Your local electrical trade school may offer preparatory courses for the Master Electrician exam. The New York City Department of Buildings website provides information about the exam and licensing requirements. I will elaborate on effective test-taking strategies that can help you maximize your score on the Master Electrician exam. Firstly, read each question carefully. Make sure you understand what the question is asking before you attempt to answer it. Pay attention to keywords and phrases. Secondly, eliminate incorrect answers. Even if you're not sure of the correct answer, you may be able to eliminate some of the choices. Thirdly, manage your time wisely. Don't spend too much time on any one question. If you're stuck, move on and come back to it later. Fourthly, answer all questions. There is no penalty for guessing, so make sure you answer every question. Fifthly, review your answers. If you have time, review your answers to make sure you haven't made any mistakes. Sixthly, stay calm and focused. Try to stay calm and focused during the exam. Don't let anxiety get the best of you. Seventhly, use the process of elimination. If you're not sure of the correct answer, try to eliminate the incorrect answers. Eighthly, look for keywords in the question and answers. Keywords can often help you to identify the correct answer. Ninthly, trust your instincts. If you have a gut feeling about an answer, go with it. Tenthly, don't change your answers unless you're sure you made a mistake. Your first instinct is often the correct one. Let's delve deeper into specific articles within the National Electrical Code that are frequently tested in the Master Electrician exam. Mastering these articles will significantly improve your chances of success. Let's discuss Article 210, which covers branch circuits. Branch circuits are the wiring between the final overcurrent device and the outlets. You should understand the different types of branch circuits, such as 15 amp, 20 amp, and 30 amp circuits. You should know the allowable ampacity of conductors used in branch circuits. You should understand the requirements for GFCI protection in branch circuits. You should also know the requirements for arc fault circuit interrupter, known as FSI, protection in branch circuits. Now let's talk about Article 220, which covers branch circuit, feeder, and service calculations. This article provides the rules for calculating the load on branch circuits, feeders, and services. You should be able to calculate the general lighting load for different types of occupancies. You should be able to calculate the small appliance load for dwelling units. You should be able to calculate the laundry load for dwelling units. You should also be able to calculate the demand factors for various types of loads. Let's discuss Article 250, which covers grounding and bonding. Grounding and bonding are critical safety measures designed to protect people and equipment from electrical shock and fire hazards. You should understand the purpose of grounding and bonding. You should know the different types of grounding systems, such as grounded and ungrounded systems. You should understand the requirements for grounding electrodes. You should also know the requirements for bonding different metal parts of an electrical system. Let's talk about Article 300, which covers wiring methods. This article provides the requirements for installing different types of wiring. You should be familiar with the different types of cables, such as non-metallic sheath cable, known as an M cable, and armored cable, known as AC cable. You should know the allowable uses of different types of cables. You should understand the requirements for installing cables and conduits. You should also know the requirements for supporting cables and conduits. Let's discuss Article 408, which covers switchboards and panel boards. Switchboards and panel boards are used to distribute electricity throughout a building. You should understand the requirements for installing switchboards and panel boards. You should know the requirements for overcurrent protection in switchboards and panel boards. You should understand the requirements for grounding and bonding switchboards and panel boards. You should also know the requirements for working clearances around switchboards and panel boards. Let's talk about Article 430, which covers motors, motor circuits, and controllers. This article provides the requirements for installing motors and motor control equipment. You should understand the different types of motors, such as induction motors and synchronous motors. You should know the requirements for motor overcurrent protection. You should understand the requirements for motor control circuits. You should also know the requirements for motor disconnecting means. Now, let's discuss some final tips for success on the Master Electrician exam. Firstly, get plenty of rest the night before the exam. Being well rested will help you to stay focused and alert. Secondly, eat a good breakfast the morning of the exam. A nutritious breakfast will give you the energy you need to perform your best. Thirdly, arrive early for the exam. This will give you time to relax and get settled before the exam begins. Fourthly, read the instructions carefully. Make sure you understand the instructions before you start the exam. Fifthly, stay positive. Believe in yourself and your ability to pass the exam.